Okay, so we want to look at, this is number 4B, and we want to show the degrees as degrees, minutes, and seconds. Whenever you're looking at changing from degrees to minutes and seconds, what you're going to do is you're going to leave, if it has a whole number of degrees, you're going to leave those alone. But any decimal, what you do is you multiply it by 60. And so and the reason why is because think about minutes and seconds. They are 60 minutes, 60 seconds type of thing. And so when we multiply 0.5 by 60, we get 30. And it's an even number, so we can stop there. So 0.5 degrees becomes 30 minutes. And therefore now it's without any decimals. The 17.48 degrees, again, the 17 we leave as is. We take the 0.48 and we multiply it by 60 and we get 28.8. So that means we have 17 degrees and 28.8 minutes. Well, I can't leave this 0.8 minutes. So I'm going to take the 0.8 from the minutes and multiply it by 60 because there's 60 seconds in a minute. And when I do that, I get 48 seconds. So that now changes that to 17 degrees, 28 minutes, 8 seconds. And so whenever you are looking at this, you're always going to multiply the decimal portion by the 60 and keep doing that for the minutes and then the seconds. Okay? So then we look at this figure, and we're wanting to find x. We're wanting to find this angle. So in order to find this angle, what happens is we have this 7-sided figure. We have 7 sides. And we know that the degrees in here have to add up to something. Well, what happens is the sum of the angles are always going to add up to 180 times n minus 2, where n is the number of sides. So we always take however many sides we have, we subtract 2 from it, and then we multiply it by 180. Think about a triangle. A triangle has 3 sides. Well, 3 minus 2 is 1. 1 times 180 is 180. Okay. The sum of the angles of a triangle is 180. So 180 times 3 minus 2 gives us 180, which that's what those add up to be. So here we're going to take 180 times 7 minus 2. 7 minus 2 is 5. So that's 180 times 5. So the sum of these angles have to be 900 degrees. So we need to add all of these degrees up and see what those add up to be, and then subtract that amount from 900. So when I add all of those degrees up, I should get 760 degrees. I subtract that from 900, and therefore x is going to give me 140 degrees. Again, the sides of the angles, the angles all have to add up to 180 times the number of sides minus 2. Okay? Now then, here's where we have this problem. So one of the things is, notice these two little marks. This means that this is an isosceles triangle. Notice these little marks meaning that these two angles are equal to each other. So since these two angles are equal to each other, I can set x minus 18 equal to x divided by 2. And the reason why I'm going to do this is this way I can solve for x to begin with. So whenever I solve for x to begin with, the first thing I want to do is I want to get rid of that denominator. We don't like denominators. So I multiply both sides by that denominator, and that gets rid of this 2 on this side. And when I get rid of that denominator, I have to multiply every single term by that denominator. So I get 2x minus 18 equals x. I have x's on both sides, so I'll subtract a 2x from both sides. That way these cancel out. This will leave me with a negative 18. Wait a minute. Hang on. See, I screwed up. 2 times an 18 will actually give me a 36. So it should be 2x minus 36. I forgot to just multiply my 2 times my negative 18. Then I subtract the 2x from both sides, and I get a negative 36. 1x minus 2x gives me a negative x. Well, I can't leave it as a negative x, so this becomes a negative 1x. I divide both sides by a negative 1, and when I do that, that says that 36 is equal to x. The reason I want to find what x is because I need to figure out what these two angles equal up to. So 36 minus 18, that tells me that this angle is 18. 36 divided by 2, that tells me that this angle is 18. I just discussed angles of a triangle have to measure up to what? 180. So if I subtract 18 and 18, 180 minus 18 minus another 18 will leave me with 144. And that is what this angle has to equal up to. Okay. Now we have to look at these figures. Looking at these figures, there are some things that we can look through these items and immediately eliminate. So this one is saying that we have 3 sides that are congruent. Well, looking at my figures, it doesn't tell me that any of my sides are congruent. So I can mark this one out. Side angle side. It actually only gives me one side of each of the triangles, and those two sides are not congruent. They're not the same. Therefore, I cannot select side angle side. All that I am given that are congruent are 2 angles that are congruent. So all I could possibly select is angle angle. Then looking at these two, I go from ABC which is this triangle, to BEF, which is the second triangle, and I look at those two sides, and it's 3 to 8. In other words, you're looking at what the scale is. So you're looking at this 3 to 8 scale. But again, I can't say it's side angle side because I don't even have two sides that are congruent. I don't have three sides that are congruent. So those are things that I can mark out immediately. Now let's look at this one. This one's a little bit harder for me to look at because the triangles are turned. So what I'm going to do is I'm actually going to redraw these triangles so that my angles and everything are the same. So I'm going to say that this is B, C, and A, and no, I cannot draw my triangles very well, but I can at least see them. And then I'm going to draw another triangle over here. And I want my right angle to be here. Well, my right angle was D. And I want my single angle up here to be E. My side that goes from D to E was 12. And so that makes this angle A. And my side that went from D to A was 6. Now I can actually compare them. So this side is compared to this side. This side is compared to this side. If you can put them in order like this, that's a little bit easier for us to see. Now, a couple of things. We don't have all three sides again. Here's the thing about side angle side. I'm sorry, side angle. Side angle is saying that the two sides are equal. Not that they're just congruent or that they're on a scale, but they're actually equal to each other. I don't have two sides that are equal to each other here. These two sides are not equal, and these two sides are not equal to each other. So I cannot select side angle. I do have two angles that are congruent, that are the same. So I can select angle. And then I can look at my sides, 6 compared to 12, and 3 compared to 6, and both of those simplify down into a 1/2. Okay? Same thing with this one. I can't see this very well. So let me draw these separately. So I have angle A, angle B, and angle E. And my side here is 12. And then I have this larger triangle, which is D, A, and C. Now, this side is not just 4. This side is 12 plus 4. So that's going to be a 16. Now, if you will notice, both of these triangles share angle A. Both of these triangles use angle A, so technically, they both have this angle in common. So again, not side, not side angle side, but angle. And we look at 12 and 16, and the reason why I'm putting 16 on top is because it wants to use ACD triangle first, and then the ABE triangle second, and that's going to simplify down into a 4/3. So you have to pay attention to which triangle comes first. That's the triangle that's going to be on the top. Now this last one, it's a little bit trickier for multiple reasons, okay? So one of the things to look at is, yes, these two angles are congruent. Alternate interior angles are congruent. Now I'm going to draw my triangles separately. A, E, B with a 4 and a 3. And then I'm going to kind of look at the way these are written. ABE and then DBC. So D, B, and C. And we know that B is here. So we know that D to B is 6 and C to B is 4.5. Not 4.4, 4.5. And the reason why I looked at the way that that was written is because I want to look at which sides correspond to each other. Okay? So I do have an angle that's in common. Now let's check our sides. I have a 4 compared to a 6, and I have a 3 compared to a 4.5. Four over 6 will simplify into a 2/3. Does a 3 over 4.5 simplify into a 2/3? Well, if you divide that into your calculator, it gives you 0.66666666, which is the same as 2/3. So these two sides are congruent, so we would use side angle side. That's probably the hardest one to actually visualize or see. This last one, I'm going to do the same thing. I'm going to separate them so that the angles are in the same locations. And one thing that I'm going to do is, again, these are going to be congruent because they're alternate interior angles. Those are always congruent. So I'm going to have this where I have a 3, an X, and a 6 with these angles. And then I'm going to have this larger triangle. And then looking here, from the 2 to the 1 is 24. From the 1 to the nothing is my Y. And from the 2 to the nothing is my 28. So this way I can see that the Y and the 3 correspond to each other. The X and the 28 correspond to each other. The 6 and the 24 correspond to each other. So I know that I'm going to use the 6 and the 24 because those are constants. So I took the 6 from here and the 24 from here. So I'm going to take the X from here and the 28 from over here. And I'm just going to cross multiply. And I'm going to get 24x is equal to 168. And then I'll divide both sides by 24, and I get x is equal to 7. Or what you could do is you could say that you have to multiply this one by 4 to get 24. So 4 times what will give you 28? Or take 28 and divide it by 4, and you get 7. So 3 times 4 gives you your y. 3 times 4 will give you 12. Or you can set it up as 6 over 24 is equal to a 3 over y. So you'd get 6y is equal to 72. Divide by 6 and you get 12. Does not matter which way you do it. You would get the same thing either way. So I hope this helps. Let me know if you still have any questions.